In this video, I'm going to explain crude oil and fractional distillation and show you exactly how to answer exam questions on this topic. So what is crude oil? Crude oil is a mixture of hydrocarbons. Hydrocarbons are compounds made only of hydrogen and carbon. Most of the hydrocarbons in crude oil are alkanes, which follow the general formula CnH2n plus 2. Students often forget that crude oil is a mixture, not a single substance. Crude oil is heated so that it vaporizes. The vapor then enters the fractionating column, which is hot at the bottom and cooler at the top. Each fraction condenses at a different temperature, so they separate at different levels. At the top of the column, we have refinery gases and petrol. These have very short chains, low boiling points, and are very flammable. As we move down to kerosene and diesel, the molecules get longer, so boiling points increase and they become less flammable and more viscous. At the bottom, fractions like fuel oil and bitumen have very long chains, very high boiling points, and are thick, dark, and not very flammable. All of these trends are linked to increasing chain length and intermolecular forces. You could be given a table in your exam and asked to fill in missing pieces of information. Pause the video and try this question. See if you can include all the key points needed for full marks. To get full marks, you need to include 4 key points: heating and vaporization, the fractionating column, the temperature gradient, and that fractions condense at different boiling points. If you miss the temperature gradient or condensation, you will lose marks. This is exactly the kind of answer examiners are looking for. One really common mistake is saying crude oil evaporates. In chemistry, the correct term is vaporizes, because the crude oil is heated and turns into a gas. Using the wrong word can cost you marks. Another mistake is not mentioning the temperature gradient. You must state that the column is hot at the bottom and cooler at the top. Students often forget to say that the fractions condense, which is essential. Finally, many answers don't link this to boiling points. You need to clearly state that different hydrocarbons have different boiling points, which is why they condense at different heights. If you include all of these points, you're much more likely to get full marks.